Okay, and hello everybody. Welcome back to a next episode, if you can call it like that, to Pixel Painter Challenge. So last time we were, last time we've done quite a lot of things with the forming of the actual on-the-spot lines when it's valid. This is still an issue, which I guess we'll fix today. Another issue we had was that there was no limitation on crossing lines, which then would erase it. We looked into it, and I was initially thinking, like, you know what, I should not clear this highlight and blah blah blah, so I have to remember it, those kind of things. But it's just easier to discover a invalid crossing and then just clear the previous highlight again. So that's the plan now. I didn't really do much to prepare because again it was a pretty busy week. But honestly, it's not that difficult to know when two lines cross. For instance, if you take the line from here to here, and then you have this line here to here, why does it cross? Well, it's because this point is left of these 2 points, and then you have a point which is right of those 2 points. I think I by accident may have clicked. Anyway, besides, there is also a thing that I realized after the session last week, was that I'm now doing a lot of click-based things, but actually, I still have to look at how it's going to work with touch, because with touch you can't just do touch and then highlight somewhere else. You can't. Although of course I can click and then I can hold, move, and let go. So I will have to see what's the most intuitive. Clear highlight, highlight. I have to go to the it's valid line. I'm also gonna do get line position. So that is get line position. Now those are all the things in between the line. Is valid points. Is valid tile position. Okay. Private bool crosses other lines. I'm not sure why he's suggesting delta x. So what does that mean? How are we going to do it? Well, first of all, we're going to do that. If not is return is valid line and not crosses other lines. Yes. That basically doesn't change anything because this will always be true. Well, crosses other lines will always be false, so it will always be true with the extra logic, and then it will remain the same. But so what do we do? I do a minimum, because as I said, what you just have to check whether your point is either left of it and the other is right of it, or this line is below it and the other is above it. It can also be a combination of the two. For instance, you can be left and below and right and above. That doesn't really matter. You just have to check with this line. If it's for instance, if this would be a horizontal line, and I want to check whether this line crosses, then again here you can see, well, this line may not be so this line is not going to be left of this line, and this point is going to be right of this line. It's also not going to be below it and above it. So I think I have to do it in both directions. Because both points are actually below it, yes. Okay, so I do math.min of start.x and x. I'm actually thinking whether this makes sense to do math.min, because I will need the max as well. I will need both min and max. So either I can do math min and math max, or I can just do if, and then I assign both of them. But then I have to do 4 lines. Yeah, no, I'm gonna do 2 lines. Okay, so this is int min x, int max x. Okay, I was hoping I would suggest it. And then this is going to be very painful, so I will have to see. Do I actually ever already have it somewhere? No. Now I have to actually check for all my points. Let me think how I do a for loop again in C#. Do they have a for off? Do they have? I assume so. Weird, I never. In here I also didn't redo it. For each. They do have a for each. So this actually I can probably rewrite as well. Okay, so but let's try that on this one first. So I have a for each. Plus points in points. Actually, this is not gonna work. Oh, okay, because I need both. So I say for int index equals 0. Yes, has to be okay. Points. This is the current points. Let's see this. This is already called start and end. It actually should also be start. This is actually an interesting approach. I'm not sure if this is correct. So what my code team here is suggesting is that I can compare it based on a point level. I can just see like if one point is below it, another point is below it. Points. But this I think is only if it overlaps with a single point. Point at x is larger than min x, so it would be here. And point x is kind of like a max, so it would be in here, and I have a point in here, yes. Oh no, actually, because I can also do it on a different level. And point y is. So if I do like this, it can be basically anywhere within the square. This is a very bad implementation. This is not the correct implementation. This is. I'm not sure because basically with the min x, max x approach and min y, max y, you basically take this point, you take your other point, you take this point, you take this point, and you technically only have enough information to actually create the box around it. Because you only have this point and you have that point. You don't know. Well, I mean, of course, I know directionality, but because I know this is start, this is end, but that's the information you have. With only those points, you don't really know what it is. And if you then say, well, I have another point which has to be somewhere between this x and somewhere between this y, and that's it, yeah, then you only care when you care about all the points that actually are in this box, and then you say, well, any point within this box overlaps with this line, which is not true. And that's what Squidbeam here is saying. Points y smaller than min y, larger than min y, and smaller than max y, and the same here. So he's just saying this line would overlap with any point in here, which is not true because I can have a point here which goes up, which is perfectly valid. I can have a here which goes up, which is perfectly valid. So that's not. That's better. Right, so I will call this line start and line end. Although of course this is also a line. I should really have line min x, line max x, line min line max yes. And now with the correct comparison, all you have to check is if min x, so if this x is lower than the line max x, no, I would say line min x. I mean, like if I have a line, I want to check whether the other line is I have a line from here to here, but then it's the other way around. And this should not be end, it should be or. Since I have a line, yes, I want to see, can I draw this line? If I have a line that goes from here to here, and I check, well, my min x is not, well, my min x is smaller than line min x, my max x is larger than line max x, which in this case would not be true. There's still going to be an edge case, I think, where both of them fail. Line min y. Interesting, because here actually wrote is correct. Okay, I'm gonna see what this one does. I think there's still an edge case where it doesn't work. So once I do this to here, okay, apparently crossing one. Put it back on collapse mode. Otherwise, it's going to be very annoying. I wonder whether it actually will remember state. Let's just start again. So I draw from here to here, crossing one. So I can't draw here because it's crossing one. Okay, and that's because of my smaller than or equals, I assume? Why is that the case? Let's see again. I draw from here to here. Because, yeah, okay, it's smaller than or equal, and my max is that's because technically it also does cross. It crosses on the start point. So I probably have to eliminate my start points. Would it be enough? Problem is I don't know the direction of the start point. So I don't know which one of the two the start point is. Can I say it has to be? It can be, yeah. For instance, just going back would not be allowed. Would going back be allowed? When you just have a line, are you allowed to just make a line? Good question. I don't really know whether you should be allowed to make a line. That's something we can think about later if we're actually trying the game out and can do things. For now, let's say it's not allowed. So a line is not allowed. And how am I going to prevent this one point from marking everything as being crossed? So this would not be allowed because it actually crosses. And I think I just really have to compare it with both points always. I have to compare my first point with a line, and I have to compare my end point with that line. Hmm. Hmm. So this one does not work. So what is it then? Okay, there they're doing the same. Let's see, plus plus. So they're saying a point lies on the line, but I actually don't really care whether a point lies on the line. They check the orientation. That's the only way to know it. We're actually looking at orientation. There's no easier way. Okay, yeah, these are algebraic. Okay, I'm trying to look up some examples. There are some very good ones. There is a okay. Well, there is a very weird, very weird algorithm, and I don't realize, or I don't think, I don't see how that's working. It's basically seeing whether points are counterclockwise, and then just comparing whether they are counterclockwise. Would that really work? Well, it's not so much checking. It's checking whether they are the order in which they are counterclockwise. Think of two line segments A, B, and C, D. These intersect if and only if points A and B are separated by segment CD, and points CD are separated by segment AB. Okay, yes. If points A and B are separated by segment CD, then ACD and BCD should have opposite orientation. That's some advanced thinking. Okay, so I have a point A, B, and I have C, D, and then he says A, C, D. No, if points A, B, should be A, C, D, A, C, D should have opposite orientation. ACD, BCD, and I have B, C, D. Meaning either ACD or BCD is counterclockwise, but not both. Therefore, calculating if intersects is as follows. This actually is a really interesting. This is a really interesting solution actually. So the idea here is, I'll see if I can briefly show it with. If you have a line like this, and then you would have a line from here or somewhere else, from here to here. Can I do it with paint? Paint, and I have to add paint to the screen. Plus window capture. Existing. No, cancel. How do I do it again? Video capture device. I think I have to create new. Okay, no, correct. Got it. Okay. So the idea is I can do lines here. No? So if you have a line, you have another line, and then we call this A, Why is this italic? That is weird as hell. A, this would be line B, of course. This is C, and this is D. Can I move this one? No, that's the annoying thing about Paint. Once you play something, then you can't move it. Anyway, so the diagram goes as follows. The only way A, B can intersect with CD is if the direction is opposite. It's not so much the direction of this line, because I mean, like this line, of course, is opposite. But yeah, what is the direction of a line? This line can be like this, and this line can be like that. And that's why you see a lot of algorithms as well focusing on orientation. What's the orientation of the line thingy? It's to calculate the actual intersection point. We don't really care about the intersection point. We only care that we know, does it intersect? If you want to calculate the intersection point, then indeed you have to kind of express this as a mathematical formula, which you can do because we basically know that either it's horizontal, vertical, or in 45 degrees, which would be really easy for us to actually put it into a mathematical real functional expression. So this algorithm actually says what you have to look at is you have to look at A, C, D, and you have to look at B, C, D. And then you will see that these go counterclockwise, and this goes clockwise. And if that's the case, then they intersect. So, can I make it? I cannot make it bigger. No, don't save. And so, for instance, if I would take a line here, and let's now, for fun's sake, what actually happens if I put them on the point? So this is A. This technically becomes B and C, and this is D. So do they intersect? Well, technically they do intersect because of the point BC. And so again here, what do? You do A, C, D, and you do B, C, D. Yeah, BC is 1 point, D. So I'm not sure whether this one will actually figure out, because this is definitely clockwise. And I'm not sure whether this will be considered clockwise or counterclockwise. That depends a bit. You do C, point A. So it would be B, C, D. Oh my god, that's annoying, because B, C, D, then this is B, C, D, this is D, this is... I think one of them will become 0, and then... Oh my god, that's annoying. Right, so A, B, C. So B becomes A, this C becomes B. No, it's not. A, B, C. C becomes D. I have to look for points where A and B are both used together. As in the second term over there and the second term over there, and both be 0. So actually it would return false, because 0 is not larger than 0. So it's not counterclockwise. So this would also say it's clockwise. So technically, if I would use this algorithm, then it would even say that this is technically not overlapping, which is actually very good for me, for our implementation, for our use case. Of course, if as soon as the point goes off and would be like here, yeah, then it would be counterclockwise, because first you go there and then you go there. Oh, okay, so that's an interesting approach. The question is, can you prove that that's always true, counterclockwise versus clockwise? I think you probably could at some point, or you could somehow do it, because if you have a line here and you have a line here, which don't intersect, it's all about triangles. That's an interesting thing, and I might actually want to at some point try to prove that this actually does always work. Because again here, okay, so which one do we take? We take ACD, so this triangle here, which goes clockwise, and then you have BCD, which is this clockwise, which is counterclockwise. Huh. Sir? Ah, okay, wait. I'm wrong. So actually it says the algorithm is not, I've only read the block up so far. Should have opposite orientation, meaning either ACD or BCD is counterclockwise, but not both. Therefore, calculating if two line segments A, B, and CD intersect is as follows. ACD is counterclockwise. That's in our case false. And then BCD cannot be counterclockwise. So CC to counterclockwise of ACD is different from, that's in this case true. And ABC, he also does ABC. ABC, that's also clockwise. It's not equal to ABD. ABD. Ah, but that is clockwise. Okay, so that is clockwise. So that's both of these would be clockwise. That would be false. And then what if I move this line? Okay, I'm gonna do a new line again. Let's try it again. New. Not saving. Damn you. Don't save. Line. Maybe a bit further. Let's try again with the point. Where you have A, B, C. And then here you have D. Technically, that's another good question. Whether there's a difference between D and C in the orientation, if this would be D and this would be C. I don't think so because it always compares the pairs, so would be fine. So you have the triangle ACD, 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 that's clockwise. You have the triangle BCD, BCD, which then I guess would be considered clockwise as well. So this actually would return, it's not different, that's already false. So the intersection would immediately say false, I guess. BCD, counterclockwise, false. Verschil is not equal to, it's not equal to, that's already false. And then doesn't matter, which is and. Who cares? It's false, so it can only be false. So this should also not intersect, the algorithm says. Okay, and then if I put my line like this, then of course it will intersect because we saw hopefully that part as well. We said A, B, C, D. And I have a triangle ACD, ACD, which is clockwise. I'll take my red again. Then I have a triangle BCD, BCD, which is counterclockwise. So currently the algorithm would say it does not intersect because those two orientations are different. Actually, the orientations are different, so it would say it would intersect. It's only if they are equal that it doesn't intersect. So this already intersects. And then it's, I think, why does it still need to compare the other two directions? That's probably because of, you have to compare A, B, C and A, B, D. That's maybe because of the orientation and direction of your lines. Or maybe the way they can intersect. If they would intersect the other way around, if I, for instance, would make this A, back again, A, this B, call this C, and this D, then with green, what would it be? It would be ACD, that's ACD, that's counterclockwise, and then it's BCD, BCD, and it's also counterclockwise. No, that's clockwise. So that will also already immediately return true. Ah, wait, both have to be true. So just because I say this is true, and because the counterclockwise direction is different, yes, and the other one has to be true as well. That's probably to avoid fall. Ah, yes, of course, that's to avoid fall positive in case this line actually was higher. Yes, yes, yes. Okay, I see, I see, I see. That's why you have to still do both of them. You always have to check for these triangles. That's the idea. You always have to check two triangles. How would you actually even prove that this actually is correct? With the triangles, the direction of the points counterclockwise. I'm not even sure that you can prove that with triangles. Anyway, so let's implement this. So they actually implemented a helper, but they gave it a very bad name. Start, middle, and end. And then let's see if this is correct. End minus start, let's see, is minus, end minus start, yes, times middle, times start, middle, times start, yes, that's also correct. And then he does larger than, not bigger than 0. But I think that actually technically is the same. And this is also not the same. He does not do end, he does middle, middle minus start. Okay, that's the same. He just changed here the orientation. So I can also indeed do end minus start. No, it's not the same because it's y. Wait. This is y. Yes, this is x. Okay. And here he says, let's see what I see online. This is middle dot y minus start y times, and then it is end dot x minus start dot x. So this is what he wrote online, and this is what I found here: end minus x minus start and x. Okay, that actually was exactly the same. Okay. So this is the algorithm, and then the crossing becomes rather easy. Okay, then it's just counterclockwise. Also, he does both, and I think that is for okay, right. ACD different from BCD, ABC. Okay, Boolean crossing line start equals counterclockwise, not line start, that's AC, that's start with CD with line start, line end. That has to be different from end, line start, line end. So that is really to see whether AB crosses. Or whether AB is separated. A, B. Okay, how do we call this? Line separated, which is a bad name because it was also going to be a line separator. Boolean, bool, line separate. 2. I have to see for better technology, and there it is counterclockwise. And then it's not, and it's A, B, C. So there it's start, end, line, start. And different from counterclockwise, start, end, line, end. So you can see that the nuances. And then I say if line separated 1 and line separated 2, then true. Else return false. And then I still might have to do checks upon the points because that might be problematic. I don't know. Okay, the only problem is that it doesn't detect properly the 1 points. For instance, that's also why I'm allowed to do this. I can't go further because there it crosses, which is correct, but this is not tackled correctly. And I think I can easily fix that actually by making this larger or equal. I think there is a tiny problem with the algorithm, tiny bug in the algorithm. The problem is if I do this, then this will also say now crossing again, of course. Oh, and this is not being marked as crossing, so maybe my change is... I think the algorithm does not work. Let's keep it like that. It does not work. See, no, the algorithm does not work because a line that is on the same horizontal line does not work. So I have to go for a more advanced algorithm, which is a bit of a shame. More complex. I actually thought I had a very easy way of calculating myself, but that's not the case. Apparently everybody's also shouting that you should call them segments or something. Mathematically. There are a lot of mathematical proposed functions. which is all regarding to see whether it's on, when you take one line, where you see is it on the left, is it on the right, is it collinear? I'll probably have to do something like this now. What does this guy do? He takes a segment x1, i1, x2, i2, segment to x3, okay. The abscess xa of potential point of intersection xai must be contained in both interval defined as follows. We said xa is included into so he's checking, he basically here is checking to see where the intersection point would be. And then he does a mathematical formula, yes. And 2.3, and then he basically just calculates the formula. Create a triangle size. It's very interesting how another guy has an algorithm where he calculates the triangle size and then checks whether the size is larger than 0. Shouldn't the size always be larger than 0? It's a triangle. How can the size of a triangle be 0? Or small, negative? I think size is a wrong word for it. And that's probably also because of the counterclockwise, clockwise, those kind of things. Okay, but I think the other implementation actually seems better. And I think it's about the same as this, no? Unbelievable, but I thought it would be easy to discover whether a line intersects or not. Turns out it's not that easy at all. Well, I mean, like, we do have mathematical equations, so maybe I should go for this, guys. A1, A2, B1, B2. How just confusing. I mean, I was always very good at mathematics, but now that I'm more into programming and I've started giving everything meaningful names, it all of a sudden becomes really difficult to read mathematical equations because they're all just letters. Good luck. Good luck. I mean, I can just copy it, but I don't want to just copy it. I want to understand it. Plug this value for t back in LT and you have an intersection point, of course. Yes, of course. D assumes. Of course, D assumes, that is not even English. The caveat that D minus C times B minus A different, where the lines are not parallel. The most comprehensive and easiest to implement answer I have found. Yeah, well, I can't seem to comprehend it. I'm not sure. Yes, that's what they're all basically suggesting the same. Huh? You just have to calculate the intersection point. Except, of course, if you have lines that are collinear. This is collinear, they call it, where they're on the same level. I don't find any proper. I want to have a proper mathematical solution, you know? I mean, parallel lines. And so what happens if two lines are parallel? Use the following example. Again, we have two lines, but this time same slopes. Okay, yeah, this is a mathematical. Okay, I think probably writing it down as a real mathematical formula is probably going to be the, well, this is going to be the easiest. Well, I know min and max, so that's okay. And I mean, like, either we have x equals a certain number, we have I equals a certain number, or we have, I mean, that's so if I do this, then I just have the formula x equals this. If I do, if I do this, then I have y equals a certain number. So not that difficult. And then if I have the line this, that's the only line where you actually have some real equation which says y equals x, but not truly. Well, actually, in this case, it would be minus x, I guess, plus a certain offset. Hence, which brings me back to what I had first, where I say I say int min x. So now this, I mean, like, if a line is like this, then the min and max of y is the same. And it will be fine. Wait, let me think. This is a mathematical equation. Should I do the same here? Maybe not, huh? I want to know. I think that's maybe what I did wrong in the past. I want to check if line start left of line end right of line, and then I have line start below of line and line end above of line. That's only the case, of course, if it's a horizontal one. Well, actually, even if it's a horizontal one, then I don't even care about left off. Then I care whether it crosses. Do I care where it crosses, of course, but I also care where it crosses. Because a horizontal line here, and if I then have a vertical line here, of course they do not cross, even though my line start is below the line, and my line end is above the line. But my line start, yeah, left of line. What does it even mean, left of line? There's no such thing as left of line. It's on the line, so it's in the line. So I think we have to play with the beginning and the end, min max. So if the line starts between line, and line start is between line, the x, horizontally, you know what? This is I don't need a very complex system. I wouldn't call it delta x. Okay. Line start should I just look at to see which case I actually have? Min x, min x, delta x, max x minus min x. So I mean, if one of these is 2, 0, if, means we say if delta x equals 0, let's if delta y equals 0. I mean, these are two very easy cases. If delta x equals 0, that means, here, let's say I have a vertical line. I really don't like, that's why actually, well, this actually is better. Horizontal line. So in the case of a vertical line, I just have to check whether we are left and right of it. And so I actually have to check whether my y is between. So I have to say int line min x max x. Okay. If delta x equals 0, so that means the vertical line, then I have to check that my line min x is larger than min x, and line max x is smaller than max x. So that means that my it's a vertical line. That the min x and max x is 0. What am I doing? So this x is 0. So what do I have to check? I have to check the y, whether the y is below it. I have to check that my min x is smaller than min x, and that max x is larger than min x, because I mean min x and max x, it's all the same. I can of course do it like this, and it seems more interesting. Line x is smaller than min x, line x smaller than max x, but it's going to be the same, so it doesn't matter. Okay, so that's one. And I mean, of course, if I have a line from here to here and I have the line over there, that doesn't work. And I have to say line min y because this could be also a vertical line. Huh? Horizontal would be easier as well, but this is a vertical line. It's a vertical line. Line min y is smaller than min y. And is this enough? Is this enough? Now I'm starting to doubt again whether this is correct or not. So I have a horizontal line. If I have a vertical line here, I know that my x is good. My x crosses. But now I have to see whether my y crosses. So if my y goes from below the max to above the max, even then it's not enough because I can go from here to here and it actually does not cross this point. I have this and I have here this point. It's above it here as well. This is above it. If I go here or even here, then it actually crosses above it and it doesn't really cross. Even though this one is below the maximum and this one is above the maximum. So how can I do this? Of course, I can't also just check whether it goes from below this point to above this point, because I can cross from here to here as well, and then actually does cross. Mathematical equations. So maybe I do need to find the mathematical equations. So in this case, what actually does matter? If I say y equals a certain value, y equals 7, for instance. Y equals 7, and I have my other mathematical formula. I have my x1, y1, and I have my x2, y2. Then basically all I need to know is 7. Well, 7. If my point, oh no, if I equals 7, because my x goes from I have a vertical line x. Why do I say y equals 7? Y is not equal 7. I'm in the case where I say x equals 5. What do you mean x equals 5? No, if I say x equals 5. Tick, 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 tick. This is the x grid. If I say x equals 5, then I say, yeah, vertical line. Okay, so I'm in the wrong case. I'm in the case where I say x equals 5. X equals 5. So I say x equals 5 in this case. X equals 5. Or x equals 7. Don't care, but I'm saying x equals 5. Then no matter what, y, actually that's also not true, because it ends. But then I have to check, okay, so I have x1, y1, 2, x2, y2, and then I guess the formula, the function, what is the line? The line for 2 points is actually, I think, can I just calculate the slope? I do know the slope. The slope is either 0 or 45. That's not so much the problem. Okay. I'm sorry for this episode, not really doing anything. It seems that I thought it was going to be very easy getting to know how or when lines intersect. I will definitely look this up a bit more offline, prepare things, because it seems it's a lot more complicated than I thought. Unfortunately. So I will definitely pick this up next week, and off camera I will make sure I have a working algorithm, and then I will come back to it next week. Okay, see you then.